All right, everybody. I think we are going to get started. It's 3:05. Hello, welcome to my talk. My name is Seth Larson. I work for the Python Software Foundation as the security developer in residence. I work primarily on the Python runtime, so like CPython, but also packaging tools, packaging standards, and kind of more generally just like the entire long tail of Python packages. And today I'm going to be talking about Phantom Dependencies. Is your requirements.txt haunted? Spoiler, probably. So let's get started. Oh, uh-oh. That's not, oh no, that's not right. Did somebody turn on dark mode? Wait a second. Wait a second. Do you hear that? I think it's coming from your requirements.txt. Oh no, it's Phantom Dependencies. All right. Okay, that's enough. We can have the lights back on. Okay. So Phantom Dependencies, they're out there. They're probably in your applications right now. But they're nothing to be afraid of if you know that they're there. Let's learn what they are and how to find them. So here's what to expect from this talk. There won't be any more jump scares, promise. But no promises about the heebie-jeebies about the state of vulnerability scanning and SBOMs and all of that. We'll learn about Phantom Dependencies. We'll do some manifesting. And finally, we'll answer the question on all of your minds, is your software vulnerable? So Phantom Dependencies are a problem because it's tough to know what your software actually is. In short, the call is coming from inside the house. This is especially true if you have to explain what your software is to another piece of software. Like, how am I supposed to tell my computer that I vibe coded my entire application, or I copy pasted from Stack Overflow if you're old school? Let's get specific though. So the term Phantom Dependency was coined by Endor Labs in 2023 in their supply chain security report. The quote is, Phantom Dependencies are dependencies used by your code that are not declared in the manifest. So to understand what a Phantom Dependency is, we need to know what a manifest is. So what is a manifest? It's a list of software. So a software manifest, it's all your packages that you probably have installed for your application. There's a few familiar faces here. These are kind of Python specific, right? Requirements.txt, there's a few different lock file formats depending on what CLI you're using, PyProject Toml. But then there's also like pip freeze, which is like, that's not really like a file on your system, that's like pip getting a list of things. And how is it able to do that, right? It's probably looking at something. So let's do a little demo to start things out. I hope everyone made their live demo sacrifices at the door before attending this talk, because otherwise I'm in trouble. So I am running right now a version of Python, 3.13, the latest, right? And I'm going to install a Python package called Pillow, which, who here knows what Pillow is? Has anyone ever heard of Pillow? Okay, a lot of hands. I'm happy about that. So Pillow is an image processing library. It handles all sorts of formats like PNG, JPEG, all of that, right? And let's run our pip freeze really quick. People probably can't see from the top. Python-m. Can people see, by the way? Do I need to make it bigger? Okay. So we're running pip freeze, and it says one thing, Pillow, right? That's what we expect. Is that what you all expect? Well, what if I told you there's probably more there, right? Let's run a tool that is like designed to do all of these things. So this is just a script to run sift, which is an SBOM, like manifest scanner, right? And all it's doing is it has a little bit extra configuration to run for directories. So I'm scanning my virtual environment right now. And it's telling me, okay, at the very bottom there, you can see Pillow with the version, but also Python and pip and all of that, right? This is all expected. Nothing weird has happened yet. Well, let's look a little deeper into our virtual environment and see what's there, see what we see, right? We're not here to trust our tools. We're here to get to the truth. So let's look at Pillow. And we look at this folder .libs, and we ls that, and we're seeing a lot of names that are familiar to us. Things like libwebp, libtiff, libpng, libopenjpeg, right? Where are those in our manifest? When I run sift, none of those projects came up. So maybe we'll put a pin on that, and we'll continue. Let's see what we can learn here. So let's add one more thing to our manifest list, right? We have software bill of materials. This is one that probably a lot of people have heard of. what is a software bill of materials? So thanks to generative AI and LLMs, software bill of materials have been pushed out of the tech hype cycle, which I'm very thankful for, because boring technology is a good thing. So now we can actually use it constructively, right? So let's learn about software bill of materials. Software bill of materials are not a silver bullet. They won't keep you safe from vampires. They are simply a manifest of software, but the most important component to us is that they are ecosystem agnostic, right? They don't care what type of software is in them. They are capable of describing all software. So all the other manifests that we talked about, like requirements.txt, PyProject TOML, all of that, those are all Python specific. You can't talk about like Rust dependencies or NPM or anything like that using requirements.txt. So SBOMs are for all software, regardless of what ecosystem. There are a handful of SBOM standards like CycloneDX and SPDX. Those are the common ones. SBOMs are really important for other reasons besides what we'll be using them for today, including compliance, vulnerability scanning, licensing, source code analysis, and then there's also the Cyber Resilience Act, small piece of legislation. So software is really, really complicated. It's not uncommon to have hundreds of dependencies in one software application. So of course, we really want to have our tools do the tedious work for us. So things like scanners or software composition tools are able to look at our software and then like make sense of it, right? So let's run a little human versus machine pop quiz. So I gave a version of this talk at PyCon US earlier this year, but I have faith in you all about this quiz. Okay, Team Humans, what software application is this? Anyone? Y'all knew Pillow, but you don't know this one? There we go, Python, yeah. That's great. Okay, so now let's have the scanner take a turn on it. Beep, boop. Oh, the scanner didn't know what Python was. Isn't that wild? So scanners, they look for metadata. They typically don't work by analyzing like all the files on a file system and their contents and all of that. There's just too much software out there in the world for it to work that way. So imagine a situation where you are running a scanner and you're trying to detect vulnerable software and the scanner can't tell that we're even using Python. What do you think will happen? Do you think that it'll come back with, here's all the vulnerabilities in your application? Probably not. So software needs labels to see most software. So if we put a handy dandy label on our Python, we say, hey, this is Python. And we run the scanner again, beep boop. Oh, there we go, it's Python, right? So those labels are really, really important, and that's what metadata is. So where do phantom dependencies come from? It might be really tempting to think that because phantom dependencies cause problems, that they are somehow a mistake. But in reality, they are very deliberate, and they're there for good reasons, so we can't simply disallow phantom dependencies from open source projects. So let's look at some legitimate reasons projects include phantom dependencies. So one of the big ones is bundling, also known as vendoring. It's a really common source of phantom dependencies. Bundling is including your dependencies inside of your package. This is the heard you like dependency graphs moment for pip, because pip has not one, but two separate dependency trees because of the bundled dependencies inside of pip. So anytime you're looking at pip, it's not actually just one package. It is 20 different projects all in one archive. Static linking is really similar to this too, because all the libraries are bundled into one binary, right? So like all of that code is being put into one application, and sometimes it's really hard to like tease out what the exact versions and all of that, what's actually getting used. It's really difficult, right? So there are tons of reasons why you'd want to bundle your dependencies. So pip actually helpfully documents the justifications for doing this, so we can use those. Things like bootstrapping. So if you're installing a piece of software, you need software to install that software, right? And so pip can't require you to be able to install software because it's made to install software. So it has to bootstrap itself. And so it can't assume that you have some other way to install packages. Python also, different than some packaging ecosystems, requires that there's only one version of a dependency in a virtual environment. And so if, for example, pip wanted to use an older version of something, it literally could not, because you might want to use a newer version, and that would be a conflict, right? Another common reason for bundling is that the standard library doesn't backport features for Python. So if there's this new feature out in the standard library, and you as like pip or some other project wants to use it, you just can't. You have to like take the code, put it into your project. That's bundling. And finally, portability is really important. So if you don't have to assume as much about the environment, if you just take all your dependencies and put it in your project. Another common reason for phantom dependencies is wheels. So who here has heard of the wheel format ever? I'm expecting, wow. Good job, y'all, this is amazing. Another common, yeah, so wheels, specifically many Linux and muscle Linux wheels are really, really common sources of phantom dependencies. So wheels are extremely popular for users. They mean you don't have to compile a whole bunch of C and Fortran and Rust every time you install a new version or upgrade your Python runtime. But there's no free lunch in software. There are trade-offs for using wheels, like that you need to include everything that you as a user need to run a wheel and all the software contained in it to guarantee compatibility with the target platform and the environment. So many Linux wheels in particular, they work by documenting a minimum set of libraries that you're able to assume exist on the target system, and everything else you need to bundle it in. And so what that ends up meaning is that anytime there's libraries involved, they all get bundled in. So there's these tools that a lot of open source maintainers use for building wheels that are compliant with many Linux format because they are so popular and demanded by users. So the tool in particular that I like to talk about is like Audit Wheel, but there's others for other platforms like macOS and Windows. And what that tool does is once you build your wheel, it will automatically bundle all of the libraries into the wheel and change the R path around so that they are able to import. So Audit Wheel was the tool that created that library directory from before, the pillow.libs directory. That's the tool that created that directory that we saw earlier. So finally, phantom dependencies are particularly common in Python because Python is a glue language, right? There is so much non-Python code inside of Python packages. There's tons of C, C++, JavaScript, Rust inside of Python packages. And it's like growing, right? So there's TypeScript, and Rust is a new contender there as well if you look on the far right side of the graph. And Python packaging metadata, the labels that we need for software to be able to understand our software, packaging metadata cannot represent any of that code at all, because it can only represent Python code, right? So how can we solve the phantom dependency problem? If the problem is a lack of metadata about phantom dependencies, then we would need an ecosystem agnostic manifest to record all the metadata about dependencies for scanners. Anyone have any ideas? Yes, SBOMs, an SBOM, right? So we can use software bill of materials standards to record the metadata we need about any software dependency, not just Python dependencies that's included inside of Python packages. So I've already had experience with creating software bill of materials documents for CPython specifically. CPython is this huge project. There are tons of dependencies, they're bundled, they're really complicated, they're architecture specific and platform specific. So with Python, I took a really hands-on curated approach and contributed directly to the CPython build and release process. But I knew that this approach wouldn't be scalable for the hundreds of thousands of Python packages on PyPI, right? So I have to take an automated approach. So instead, I focused on providing a mechanism where Python packages could record non-Python dependency information using SBOMs, and that ended up manifesting as Python Enhancement Proposal, PEP 770. So as the author of PEP 770, proposed a standardized directory for software bill of materials inside of Python packages. It's listed right there, distinfo/SBOMs, and this PEP was accepted back in April. And this PEP, it's basically used, the most important usage is for the tools. So things like Audit Wheel, right? They can start using this directory immediately to when they are bundling all of those dependencies, all those libraries inside of Python artifacts. They can take them and put them in that directory. And then scanners, as they start to adopt the standard as well, can take that information, parse it. They already have to support all these SBOM standards, so they're not too unhappy about that. And then stitch that information together to have a way better view of what is actually installed on a system. And I wanted to thank Brett Cannon, and there's tons of other people, volunteers, that all helped me land. This is my very first packaging PEP, so thank you to all of them. So now that this standard is accepted, what I can then go and do is I can start contributing to projects that would be sources of this SBOM data, so like Audit Wheel, for example. And usually the contributions are like pretty straightforward, right? Because the systems, they already know what they're doing. They know the state of all of the different libraries that they're trying to pull in. And the big thing that was missing was they didn't have a place to write it down. And so what the contributions end up being is like, oh, you have all this information, and now there's this new directory. Let's write it down as an SBOM. And the nice thing is that once some of these really, really popular tools start adopting PEP 770 and generating SBOM data, the phantom dependencies will be far less common because these tools there's only a few tools, and so once a few tools adopt it, there'll be a lot more SBOM data out there, and that's a great thing for the Python ecosystem. So let's do our demo again, but this time with PEP 770. So if I clear this, and if I uninstall the wheel that I had earlier, so this wheel, hello. That package did not have PEP 770 SBOM data in it, and if I install instead this wheel here, /pillow. Yep, so this wheel I compiled using audit wheel that has support for PEP 770, that pull request that I showed you earlier. So if I install that instead, and then I run sift again, it's doing a lot of indexing. Oh, and I'm gonna make it a little bit smaller so it's actually like a nice list. Look at that, there's all of our dependencies. Isn't that nice? So what we can see from that, if I clear this out, and now I have to write a really long command, and everyone, hello. So if I actually look at that distinfo SBOMs directory, if it'll let me look at the distinfo SBOMs directory, and if I make it pretty for you, so here's that bill of materials document that audit wheel generated, right? And you can see it was generated by audit wheel, and it includes all of our dependency information that was pulled from the original system. So I run Ubuntu, so it's a lot of Ubuntu system packages, all of the dependency information that was used to build that package. That's pretty cool. If I swap back to my presentation. All right, so that's the technical side, right? So I also wanted to speak to the social side, right? Because I was contributing this project to primarily community-maintained projects, things like the PEPs. Lots of PEPs are reviewed by volunteers. PIP is maintained by mostly volunteers. So it's really important to get this part right too. So this is more of like if you're trying to contribute to open source in this specific way, improving packaging standards, here's some things to keep in mind. So this quote right here is from one of the two maintainers of PIP, is also a PEP reviewer for packaging. And this was on the initial PEP discussion, right? So I just opened up the proposal. Here's my first version of the proposal, and this was what they had to say. My attitude towards SBOMs tends towards grumpy. Why should we do work in free time to make life easier for big companies? So that is pretty negative vibe, and I kind of identified right away that this was going to be an obstacle to trying to contribute meaningfully, something that I knew was important to both, corporate users, but then also regular open source users. It's really important to know that your software that you're building with is not vulnerable, right? So I knew that I had to do a bunch of work in that space to try to convince this person, educate them, make sure that they felt like I wasn't just steamrolling over them, because obviously I'm full-time employed by the Python Software Foundation. Volunteers don't have as much time to contribute to projects. And so this is kind of like the framework that I used. So yeah, let's see. So work that's associated with like regulatory requirements like SBOMs, it's somewhat rightfully seen as work that is more important to enterprises and less of a benefit to community users. And so like the question is like, why would you saddle them with having to review it? And then once you review the standard, you have to review the patches. And then once the patches are in, you have to maintain that forever. And sometimes it's really difficult to know what the maintenance burden is going to be long-term for a set of features. Is this going to be like, we write the patches and we're good? Or is this going to be like, oh, this is just constantly going to be creating work for us? And so what I've found is what they are willing to do, people that are maintaining community projects, they're willing to do their part if you do a whole bunch of extra work on top that makes them feel good about what work they're accepting into their own workload, right? So specifically, if you are willing to review the submitted code, like if you're willing to go with them, like take them along for the ride, So hiring from within the open source community goes a long way. I was already a part of the Python open source community. I've maintained multiple packages, and so there was lots of people that were in the discussion thread talking about how, oh, this person, probably like Seth already knows all of the issues and like what we were expecting, so like it's probably gonna be okay, which was really great. So like that existing trust is there, there's relationships there. For projects like this, there is a bunch of support to get like features implemented, but then after that feature work is done, there's like basically zero support for long-term maintenance, and maintainers know this. So like you need to play to that as well. You need to make sure that what you're doing, what you're proposing, answers that question. So covering the long-term maintenance story is really critical. So that's things like documentation, who would be able to contribute, how often are we expecting updates to come for this component, right? And one thing I wanted to talk about is like the final design for PEP 770 changed quite dramatically from the initial design. I based my initial design on a previous PEP that had been accepted, but throughout the process, we eventually landed in a position where we're like, oh, well, here's this way that's like, will require way less maintenance and way less work from packaging maintainers, and so it's easier to implement for tools. And that approach was so popular that they like want to go back and revise a few other PEPs because they're like, wow, this approach is really, really great. And so like focusing on the maintenance burden ended up manifesting in that really great way, right? So any project that involves volunteers and open source work should expect to go super, super, super slow. Don't expect to go fast. And that's really, really hard if you're someone who's full-time, right? Like you want to get things done and you've got all this time, 8 hours a day, you can get tons of stuff done. But volunteers do not have that. And so when I published my first draft for PEP 770, it was late November. And it was accepted in early April, right? So like, it takes a long time to get things to go right. But in the meantime, for all that time, I was spending that time creating proof of concepts, creating blog posts about the design, creating documentation, answering community questions, and then talking to like all the different projects ahead of time to make sure that they were like on board to, hey, if this design were to land, would you adopt it? I already have patches made, here's kind of how the system will work, just to try to make sure that the design will serve everyone, right? And finally, once that design is stabilized, yeah, definitely create patches, but also creating like test cases up front is really important too, because it'll show the maintainers that like, hey, I'm putting in all of this work, all you have to do is like review it, and they're gonna document the maintenance story, and it makes people feel a lot better than just this open-ended, forever maintenance work that volunteers end up having to do otherwise. So remember the earlier quote? So this is the exact same maintainer. A week after PEP 770 had been accepted. They realized that PEP 770 and SBOMs could be used for an issue that they were currently trying to resolve in pip related to dependency metadata. So reading this quote and comparing the sentiment from the beginning of the project to the end, I am pretty happy. In my opinion, this is like a really good sign that my approach for community trust and engagement was successful. So if this talk has you thinking, wow, I love having my problems that I didn't know about being solved. That's great. So I have a way to keep that happening. At the Python Software Foundation, we have a Developers in Residence program that, thanks to generous sponsors, is able to staff important work on Python, like security, the Python package index, and the core Python language. Full-time staffing is especially important for the ecosystem scale problems, which require dedicated time, and where there are many projects involved in the solution. The two security-focused developers at the PSF, me and Mike Fiedler, today are sponsored by Alpha Omega. So, back to the original question. Let's bring it home with some tips on figuring out how to figure out if your Python application is vulnerable. So, I recommend not just running a scanner directly on an application or a container image. Remember, we're manifesting here, right? I would recommend creating an SBOM first. Pointing a scanner directly at a application or a container, it means that you don't actually end up seeing the inner state of your scanner. Instead, you're just trusting whatever comes out on the other side, right? So for SBOMs, I use Sift in my demo, but there's a bunch of other ones. Yeah, and creating a manifest from your environment, I would recommend creating one and then start asking questions about that manifest. Like, am I seeing all the software that I expect? What's missing? Are there any software identifiers like package URLs or CPEs in the manifest? Because if there aren't, then it means that you're probably not going to be able to get vulnerability data for those components. And don't be afraid to poke around your virtual environment, like literally on the file system when you're doing this, because looking for libraries and license files and all of that, it gives you some clues, some interesting things you can find. So once you have a high quality manifest, we need a scanner. So as we've learned, there's a lot of non-Python software inside of Python applications. So the scanner itself for vulnerabilities also needs to support that use case. It can't just scan for Python. It has to scan for other software too, Rust, JavaScript, system libraries, all of that. So for an open source scanner, I recommend Gripe. It's the same people that maintain Sift. There's a few other options out there like Trivy. And remember to run your scanner only on an SBOM. So this lets you be much more confident about the exact software components that are being checked. And if you're using a pure Python packages with no non-Python dependencies, it's okay to use pip audit. Otherwise, Gripe is probably what I would recommend. It's much more comprehensive. Check your manifest. So where are your dependencies coming from, right? Are they all pure Python? Or maybe there's some Rust in there, some Linux distro projects. For each package ecosystem, you need to check that if that package ecosystem is providing vulnerability data, because not all of them provide vulnerability data that a scanner can pick up automatically. So my way to test this is I pick a project from each package ecosystem, so like Python, Debian, Rust, all that, right? And then I find a known vulnerability for a project, just a random project in the SBOM. And then I try to make that vulnerability show up in my scanner. Because what that ends up proving to me is that there is vulnerability data that my scanner is pulling in, and it works, right? So if you have an SBOM that you've generated of your application, what you can do is you can manually go in and edit all of the versions to be some older version that you know is vulnerable, right? And then you run the scanner. And if it doesn't come up with a vulnerability, then you know that there's no vulnerability data, or the scanner's not finding it, or something's wrong, right? Because the tough part here is that the false positive is the same as your software is secure is the same as I can't find vulnerability data. And that can be a problem for Python applications. Okay, so we survived the night. Here's the key takeaways. Phantom dependencies are friendly ghosts. They're there for a reason, they're just misunderstood. Your software dependencies can be complicated. It's common to have 5 or more programming languages in what appears to be a Python application on the surface. But it's on you as a user of open source to understand your dependencies enough to keep your users safe. Creating a manifest and investigating your software are great exercises to understand your supply chain and learn more about Python packaging. As new tools adopt PEP 770, Python packages will become more measurable and keep users safer. There's still a good amount of work to do here, but we're heading in the right direction. Packaging standards are challenging, especially working with volunteers. There are techniques to make these easier. And finally, support the PSF, the Python Software Foundation. We solve your Python problems before you even get to PyCon. And that is all I have. Thank you, slides. All the slides are available as a PDF if you want them. I'm not sure if anyone has any questions. I can take questions. We're finished a little early, like 7 minutes early. Yeah? I don't have microphones. You can project.
Yeah, well, for the video recording.
Oh, sure.
But you can repeat.
Yes, yes.
Yeah, so I'm guilty of publishing lots and lots of packages that have all these binaries in them. So what do I need to do to fix that?
Yeah, so the question is, if you publish Python packages, what do I need to know to be able to take advantage of all the good stuff from PEP 770? I would say use the latest versions of Audit Wheel. Once that is actually adopted, if you're publishing for like many Linux and all of that. And the other side of it is like running SBOM scanners on, like I just did, right? Where I just installed my package, and then just ran a scanner and saw what came out. And that's how you can like know with confidence whether PEP 770 is working or if it's not working. That would be my recommendation, or just like checking out the archive itself, just opening it up, see if there's an SBOM in there, if it looks okay. That's probably my first set of recommendations, so yeah, good question. Yeah?
I loved that you commented a little bit on like the social dynamics of contributing this PEP.
Yeah, so the question is mostly just talk about what you think the state of like falsifiability of software components inside of software bill of materials. I would say that software bill of materials right now, they have mechanisms for containing that information. Like they can already contain like signatures from Sigstore or Salsa or whatever, right? Published provenance. There's places to put the information. I think that scanners could definitely do more to take that information and be like, oh, I know that hash. I can check to see if that's like a valid thing on the Python package index. If it is, then I can just encode that into here. Oh, I can also do the same thing for all of these embedded dependencies too, which they're like slightly modified, but the patches are knowable, right? Like you can include the patch to change what changed between this checksum and this checksum within an SBOM as well. And from there, you can kind of say like, okay, well, this came from Ubuntu. All of these system libraries came from Ubuntu. They're contained with it. And then this Python package came from Python package index. I think it's more of a problem of like scanners taking that information, verifying it, and then putting it in the documents. And then you can be a lot more, you can feel better about what's in your documents, yeah. If there's no other questions, oh, yeah.
If I'm not using like audit bill directly, but using a tool, like say in my case using like Matpert instead, I assume that the path forward to adoption would be to like try to promote this in the community and get those tools to adopt the path.
Yeah, so the question is, if I'm not using Audit Wheel, how can I take advantage of PEP 770? So the magic of PEP 770 is that it's just a directory. So like, in theory, it's like pretty easy to, if you have that information in your build tool already, you just write it down, which is great. So yeah, like if it's something that's important to you and your projects are using these build tools that have that dependency information, saying like, hey, can you adopt this PEP? It's a packaging PEP, it's new. If you do, like tag me. I'm happy to like cheer from the sidelines because I've done that a bunch of times with like Meson and like Maturin, the one for Rust. And there's excitement in other build tools, so I think you can maybe like use that to like cross-reference and say like, oh, these tools are adopting it, maybe we can adopt it. So yeah, I think that's the way forward. Yeah?
Have you received any input from some of the contributors from Linux packages about this maybe?
I have not received input from Linux packages.
Nix in particular?
I haven't received any. The question was, have I received input from like system package repositories? And the answer is no. Yeah?
I was just interested if you're tracking adoption kind of across PyPI broadly, but also on the consumer side from the enterprise perspective of like, how can I tell how many percentage-wise, how much of my project is giving me an SBOM versus, this is the risk that I would be assuming otherwise?
Yeah, so what you can do and what I can do from like a public perspective, the thing to look for is that directory, right? So it's really easy to measure how many Linux wheels are out there, and you can then look to see, are they providing any libraries at all? Because some of them aren't providing any extra libraries at all. That's fine. And if they are, is there a corresponding SBOM? So like that would be my approach to that. And so I can track adoption across the ecosystem that way. But then if you're within an enterprise and you want to do that yourself, another way you can do it is like for a project that you are using, you can try rebuilding from like a source distribution and then seeing which system libraries are required to build it and which ones it links out to. And that can give you kind of a good idea of like, oh, is there supposed to be an SBOM here? Or could I generate my own for this information? Right? That would be probably my approach. Yeah. I think I'm out of time, so, or maybe not, I don't know. You can just keep asking me questions so they kick me out. Okay, well, thank you, everyone.